Hey, it's 5 p.m. here in Atlantic Canada, and so we'll start this stream. So welcome everyone. Today we want to discuss three different things. First off, we will show what we have done with Meshtastic. So we have created a integration for between Meshtastic and FTS. Second, we want to share some progresses that we have done with the implementation of Reticulum and the flock of Parrot. And then if our main developer join, we will discuss also the progresses that we have done with FTS 3.0. And we will also have some time for questions. And here you are. Oh, Ghost, can you show face? Do you have a camera so we know who you are? Because here I don't see things.
The camera's not really working right now, so it's going to have to be off camera today, unfortunately.
Okay, not a problem. So is Alex joining?
Yeah, I was just talking to him. I think he should at least be he said he was going to join, so he'll probably be
Okay.
here in a minute or two.
Okay, so let's start. So I'm going to start my screen and discuss the first topic. That is entire screen. What we have done for integrating Meshtastic with FTS. Can you see my screen?
Yes, I can see your screen. You're showing the Meshtastic deployment FreeTAKServer 2.1.
Perfect. So what is that we have done is nothing, fancy. We are using the Mosquito capability or MQTT capability of Meshtastic. And then we have in the middle Node-RED. And what is happening is that if I have any type of device that is using Meshtastic and send a LoRa message, we can have a regular communication. So that would be this. Can you see also my mouse? Here, oh, shit. Sorry. Let's go, try to go back. Oh, one. Here we go. So at the bottom of the screen, you can see we have a regular Meshtastic communication. Namely, we can have a mesh node that is communicating with another mesh node, and they go to the Meshtastic application. But then we have one special mesh node that is connected to a MQTT server. Here we're using a open source lightweight server called Mosquito. And as a consequence, if you configure everything correctly, all the messages that are, going through this mesh, they are also, if you agree, that is an important thing that is part of the Meshtastic configuration, not automatically. But if you agree to do so, those messages will be passed to this. This will pass to Mosquito. Okay, that means that in this way you can overcome distance by having one Mosquito or MQTT server that act as a bridge. So we can have communication also over very long distances. Okay, Meshtastic project as a public Mosquito or MQTT server. But what we have done is we have created our own for the sake of this demonstration. Now, the real integration that we have created uses, again, Node-RED. And what the Node-RED flow does is it listens to Mosquito. And as soon we have some type of message, we'll use the FTS special API to push this message. And that means that in WinTAG or any tag client, we can see what is happening. Okay, so let's see if that works. So here I have a device. This is a TDEC that is currently not connected to anything but the mesh. And then I have another TDEC, this one, that is connected to my Wi-Fi, and through the Wi-Fi is connected to the MQTT server. So now I will say hello world. And on this device, I get the hello world and see. But the cool thing is that if I now switch to WinTAG here, you can see that I just sent an hello world, and I will send another one just to be sure. This is again my test. And you can see that I can see that here in WinTAG. Now, additionally, you see that is beautiful Nova Scotia. And in here, I can see all the devices that are sent. They are not simply sending text, but they are also sending, their position if you clearly agree to do that. So that is how that works. Let's see a little bit what the repository said. So the repository is located as part of our organization that is FreeTAK team. And it's called FreeTAK Hub Meshtastic. So if you click here, we try to document as best as we can. Keep in mind that this is a technical implementation, and that means that can require some technical skill to be implemented. But the first step is to do some installation. So you need to install Mosquito, and here we have the full instruction how to do that. Configure Mosquito, and here you open the Mosquito configuration, and you can simply copy paste this configuration. It's supposed to work, assuming that your Mosquito server run on the same IP as FTS. Now we have the need to configure at least one Meshtastic node so that can pass messages to mosquitoes. Here we have full information about that. And then the most important thing that is really our own implementation is to configure Node-RED. So let's jump into Node-RED and see how that works. I can find it. Here we go. So as you can see, this is a kind of complex flow. Some of the stuff is currently deactivated. The version that you will find in the repository is simplified, so I deleted everything that you don't need to know about. One thing that is relevant is that Meshtastic are two different ways in which you can send and receive messages. One is so-called protobuf, and another one is JSON. So JSON, as you know, is pure text, so it's easier to use. However, is buggy, and in conversations with the developers, they say that they don't want to support that anymore in future. So what we do is we use the protobuf channel, and that required to decode the message. And then the message can be of different types. Right now, we only support two types of messages, but is kind of future-proof, because you see here we can, like in future, also detect sensors and other things. So if there is any interest. And what we do is we split here the message, and then if it's a position, we send the position to FTS. And if it's a chat message, we send the chat message to FTS. and that uses the FTS API. That is something unique. That means if your question is that going to work with all the servers? No, it's not, because FTS is the only server that is exposed what I would call a human readable API. Now let's see how that works from this point of view. So I will send another message with my device. I call it not read. And you see here, we see the fact that, like we have explained, this is a very long, way that this message is going, because fast is going from my device, that is LoRa, to the next LoRa device, and can be, different ops till will reach the device that is connected to the MQTT server. Then the MQTT server will send the message, and then Node-RED get the message, convert the message into FTS, and then create, the FTS message for chat, and then FTSAA, it works and will send a success. And we should see here again that we have received, something. Okay. Now, what is that you need to do to install the sync? Fundamentally, this is still in a beta and require from your side some understanding of how to configure things, but most of this stuff is already configured. Keep in mind that this is a so-called topic of MQTT, and currently is configured for mesh/US. That is the standard for North America here. If you are in another part of the world, you may want to configure this differently if in your device you have something different. Now, from the device point of view, what we do is you connect your device. Maybe I need to switch. Okay, so you connect your device with a serial. Probably, if you know Meshtastic, is nothing new. So now in all the devices, so there's only one device that acts as a bridge. Everything else you don't need to, set directly to MQTT. But what I discovered is that in the radio config, you see here, we have, configuration, then radio config, and then LoRa. You need to accept the fact that you are okay to send your messages to MQTT. That means that a flag will be added to your message, LoRa message, and when the MQTT bridge will receive it, know that you can be sent to MQTT. And then the other thing is in the channels, you need to configure which channels are going to be used for uplinks and downlinks. See, uplink enable and downlink enable need to be activated for the two channels. This need to be done in all the devices that you need to connect to TAC. Now, finally, future possibilities. So I explore also the concept of sending messages from TAC to the mesh. And we know how to do that. However, the real question is if we have or not a use case for it. So you see here we have already prepared everything. So we have here that is the same approach that we use for the web map. We listen to FTS messages, and when we get a FTS message that is of type chat, we will send this chat to Meshtastic. The issue is that, as you know, Meshtastic is limited in what it can do, and a typical TAC server sends a lot of stuff, so it's a serious risk to completely overwhelm the mesh. So that is all I wanted to say in regard to Meshtastic. Is any question or comment before we switch to the next topic. Okay, everyone is fine. Remember, you can still ask questions in Discord after the chat if you're kind of not willing to go on record. Okay, so let's switch to the second topic. That is what we are doing with Reticulum. So here we have the Swagger editor. So one thing that we have invested a lot of time on is if you are following this project, you know that we try to do everything from a model, so model-driven architecture or digital engineering. And what we have done is we have created a generator that can create a full API specification from the model. And that is the Open API specification of the Flock of Parrot. Now, the next step in our development, now that we have the Flock of Parrot management, will be to transform this into the code that is supported by our framework that is called DigitalPy. I will go through what the Flock of Parrot API described, and then I will let Ghost here elaborate on how is that we will support with DigitalPy. So as you can see, we have different labels here, and to kind of understand what that is about, you should be a little bit familiar with Reticulum implementation. Reticulum described a different type of network, not use IP or anything like this, but they have destinations and identities. And so the Flock of Parrot API is on the top of Reticulum. So we have certain endpoints that are managing Reticulum features. This is the companion Parrot. If you're not familiar with the concept, a Flock of Parrot is a group of FTS servers that can dynamically form a mesh, connect with each other, and also receive messages if they are disconnected for a while. The way in which will works with Reticulum is by using certain feature of Reticulum, and the first is use the unknowns. So as soon a companion parrot, so any participant to the flock show up in the network will announce itself, and the master parrot will receive this announce and will ask the companion if the companion want to join a certain flock of parrot. And if the companion agree to join, it will join automatically. Flock sync is a endpoint that will allow the companion to receive all the messages that are relevant that were published during a period in which the companion was not part of the flock or was offline. Then we have different order, get. Here we have, companion message. So is basically sending a message over the protocol. So a Reticulum is the network protocol or the network API on the top of which the author of Reticulum, Mark, has created another protocol called LXMF. And we intend to use LXMF to send code messages. Additionally, we are introducing the concept of a topic, or the fact that you may be, joining to a flock. When you interact with the flock, you can be interested in certain type of codes or topics or categories, for example, fire or whatever you can be think about can be a topic. So we have here some management of the topic flows. So propagation node is a very important concept. Is the part of the master parrot that will help the flock to maintain offline synchronicity. Namely, this is part of the master parrot, and the master parrot, as soon as you join the parrot or you rejoin the parrot, is able to send to you everything that has been delivered or published previously. And here we have the ability to create, the flock of parrot itself and to configure Reticulum. So that is what we have. So we have currently the API only, as you can see, is a lot of code, but this code is something that we generate. We can constantly expand on this as we go. Now, the next step will be to take this and generate some component for Digital Pi. And here we were waiting for Alex to join, but because it's not there, you want to say something, Ghost?
Yeah, actually, Alex is here. He's APAC. He just was missing the permissions. But yeah. So I think the kind of fundamental idea that people need to understand to kind of understand the traceability here is that the whole point of this is to be able to maintain the application in a model or an authoritative source of truth, and then use that to generate code. This, what we're looking at here, is the intermediary format. So this is an open API specification that defines the interface, which is used to generate the outline of the code base. But all of this is basically just with the intention of being able to maintain a digital twin of the code base, which is then transformed eventually into the material implementation. Like you were saying, the purpose of the flock of parrots is, in essence, to build a network of attack servers that can interoperate in a very dynamic environment. Think nodes going up and down all the time. And all of this is just the implementation to address that use case of interoperation between different agencies, groups, or organizations in a dynamic environment with very low reliability in terms of the link end of things. I think that covers the high level overview. The intention for implementing this, as you said, is the Digital Pi framework, which is the last step in the transformation from the ASOT or the model implementation to the code. And that framework is meant to enable some of the more interesting dynamic features that we hope will kind of underpin the use cases that are required for the flock of parents. I don't know how much more there is to say about that right now. But
You
this
want
is
to
kind of
elaborate on the concept of Digital Pi service and how that will fit the general idea of FTS 3.0?
Yes, yeah. So the whole premise of Digital Pi is kind of twofold. First and foremost, it's to have a framework which supports kind of the fundamentals of digital engineering, that is creating code that's modular and distributed, and that adheres to a very specific design pattern that can be easily generated with code. So you have kind of hotspots and cold spots, where most of the code is generated automatically from the ASOT, that is the model, along with its interfaces, and the implementation is what's actually coded, so the business logic. The other very important feature of Digital Pi is its support for dynamic components. The whole idea is that it revolves around components which maintain the business logic of the application, and components can be hot loaded or unloaded for that matter, allowing for dynamic response to a changing situation through software. So you can deploy en masse very quickly. Hot swaps, fixes, patches, whatever needs to be deployed across the flock. And the other part of that is that it's all based on kind of IO communication. So you could have a single FreeTAKServer server that can also theoretically, scale up arbitrarily or out arbitrarily by deploying different services across different nodes while it still runs as a single FreeTAKServer server. So maybe you have one major server that's running in some cloud environment distributed across several instances. And then another instance running on a Raspberry Pi using localhost for socket communications, but they can run with similar baseline requirements and can scale up as needed. So that's kind of
the concept that we wanted to elaborate is about the service of Digital Pi. So in the context of a tax server, already today, if you think about all the different ways in which a tax server can expose things, for example, we know that can use TCP, can also use, in the case of federation, protobuf, but over a different port. And you can use also other technologies. So recently, for example, FreeTAKServer introduced something called, if I'm not mistaken, Quick something that is a kind of super TCP encrypted. But every time that we introduce a new technology, it become complex to manage. So in Digital Pi, what we are doing is we have introduced this concept of a service that can be anything. And for example, Reticulum is yet another service that is communicating with the outside world. And then we have a conversion layer in which the language and technology that is spoken by the service is translated into the internal language of FTS. And then within FTS, we have all those different components that are independent from each other. So they act like microservices. You can install them, deinstall them, and so on. And so we have a structure that is super flexible. This also cost some time in developing it because we do everything in our free time, but we hope that the result will be really cutting edge. Alex, you want to add something? Sorry, I was not aware that you are FreeTAK.
Oh, you're okay. I came in a little bit late due to the permission stuff. Nothing that I think I could say better. So, but I'm here if I'm needed to elaborate on something.
Perfect. Okay, so that is the presentation we wanted to do of our current development. So is anyone that want to add something? So Hans, Kiefer, Doc M, any question, any other topic that you want to discuss? Okay. Come on, guys, give me something. Cool. If we don't have any further topics, I will say that we close it for now. In regard to the main topic of this video, that is the Meshtastic integration, we invite all the users to test it. Keep in mind that is a technical demonstration that is not still in production and requires some important configuration from your side. If we have enough requests, we may in future integrate that into our zero-touch installer so that the whole configuration will be simplified. If not, we will leave it as is so that each user can decide if to install it or not. And that is all I had for today. So I wish everyone a wonderful rest of your Sunday. Enjoy the cold and the snow, and we'll see you next time. Thank you so much. Bye-bye.
Thank you. Talk to you guys later.